Alright, Space Cadets. So today we're going to cover basically what we need when we're in space for a long time. Okay, so how do we get food and water in space? What are the requirements for long-term survival in space? Now, if if we're honest, this is going to be something that you guys do on your own. Okay, I'm going to set the scene today for what you need to be there, and as part of your assignment, as well as in class activities, you're going to put those together. But this is what water looks like in space. This is like water looks like with gravity. Remember, we've talked about water as a polar molecule, so it's got this shape here. Now that shape, that's what gives us surface tension because of this thing called hydrogen bonding, and that's how water looks in space. It's pretty cool. Alright, so what do we require on Earth? Basically, we need air, in particular oxygen. We need water, we need food, we need shelter, and we need to not have our crap sitting around us. Alright, so that's pretty much the same thing we need in space. But then there's some other things. So, let's have a look at the environments very quickly where, as an astronaut, you'd be spending all your time. First, we have the International Space Station, which is this here. It's in this direction here. It's 100.4 meters, and this direction it is 70 meters. Okay, so that's the dimensions. That's pretty big. That's football size big, football field size big. And yeah, basically you spend all your time living along here. There's the solar panels to power it. Sorry, and you can see here you've got the blue lines, the red lines. These are the different modules that the different crews have brought up. Okay, so we've got the models brought up by the US and the Russians and the Canadians, Japanese, and the Europeans. All right. How do you get there? Well, there's two ways. Well, actually, there's one now, but there was two ways. There's the NASA Space Shuttle, okay, which in the end was not the most efficient way to get there, and America decided to scrap that plan. And it's composed of essentially you've got the orbiter here, okay. You have the liquid fuel and hold liquid hydrogen and liquid oxygen, and these go to the three main engines down here. And then you have the solid booster tanks, booster rockets, and they're your first launch. And yeah, so, but we'll go into this in more detail. There are two ways. There was one way to really get there now, and that's this boy. This is the Russian Soyuz rocket. This is the current one here. So, basically, this is all rocket, and it is just the very end bit here where the people are, and it holds 3 to 4 people, okay, whereas the shuttle can hold about 8. So not as many people get up there, and yeah, and the Soyuz rocket, it gets you up there. It docks with the space shuttle. It docks with the International Space Station, and then you swap on for people on, people off, and they go home. And this is what it looks like without all of this extra casing. So this here, this part of the rocket, which is a single-use rocket, it lives in there. Okay, so this is the capsule where people are at. This is what steers around once it's in space. All right, that's pretty cool. We dig the Soyuz. All right, America is mostly working on one called the Orion at the moment, but it's also private industry is what they're looking at getting towards the space station. America is currently looking at for the Orion for deep space, like the moon or Mars, etc. Okay, so what is necessary for life on the International Space Station? Well, these are the things that have decided essential for it, and you need it, be suitable for people to live there. First, you need to recycle wastewater so that you can make potable water. Now, remember, potable means drinkable. You need to be able to store and distribute it. You need to be able to store it so you can, make some when there's lots there and keep it and then get it around the space station. You need to be able to use water to produce oxygen. Okay, you give out a lot of wastewater. We need to be able to use that to make oxygen. It's not like you just crack open a window when it starts to get a bit funky. We need to be able to reduce the carbon dioxide. If we don't reduce the carbon dioxide, people die. People breathe it out. Again, you can't crack open a window and it gets a bit funky. So if we can't get the carbon dioxide, if we can't filter that out, we will die, or astronauts will die. You need to be able to filter the air for particulates, so that's like solid matter and microorganisms. You need to be able to get that out. You can't just be breathing it in constantly. You need to remove volatile organic gases from the cabin. Farts. Too many farts in one room, they will explode and you'll die. We need to monitor the air pressures, as well as the pressures of all the other gases. Let's wait for the bell to finish. You need to be able to maintain the cabin pressure. Okay, if the pressure decreases, there's all sorts of medical problems. Basically, you need to be able to detect and suppress fire. Now, we can't evacuate. Not everyone can leave, so you need to be able to section off, like lock off this section here, flood it with carbon dioxide, or take the oxygen out of it to smother the fire. And you need to be able to maintain the humidity levels and the temperature. Space is pretty cold, and then it's pretty hot. We need a pretty serious air conditioner. Alright. Oh, you also need to be able to move the air around to ventilate it. That's it. That's the things. Those are the requirements for long-term staying. And remember, they're up there for months and months at a time. Alright, see you in class.